Hello everyone. Continuing from our previous video, let us see some of the more examples on pH calculation. Let us now take a case of mixing two acidic solutions. Let us say 100 milliliter of 10 to the power minus 2 molar HCl solution is mixed with 200 milliliter of 10 to the power minus 2 molar HNO3 solution. Now, in such cases, the H plus ion concentration will be contributed by both acids. So we will have to add up the total H plus ion concentration from each of these acids. The dissociation of HCl is known to us. HCl dissociates in the form of H plus ion and Cl minus ion, and it is a strong acid. So whatever is the concentration of acid, entire 100% dissociation will take place, and we will have the concentration of H plus ion to be equal to 10 to the power minus 2 molar. Okay. Similarly, HNO3 acid dissociate in the form of H plus and NO3 minus ions, and again it is a strong acid as well, so it will also completely dissociate into its constituent ions. 10 to the power minus 2 molar HNO3 will give us 10 to the power minus 2 molar H plus ions. So we have these H plus ion concentration, total H plus ion concentration from both the acids. Now 10 to the power minus 2 molar signifies that it is the concentration in 1 liter of the acid. However, here we have taken just 100 milliliter and 200 milliliter of respective acids. So we will have to multiply this molarity with volume to get its number of moles, and then again divide by total volume to get the molar concentration of H plus. The concentration of H plus will be calculated like this: 10 to the power minus 2 molar HCl solution times 0.1 liter HCl plus 10 to the power minus 2 molar H plus concentration from HNO3 times 0.2 liter. Okay, and divided by total volume 0.1 plus 0.2. This will give us the H plus ion concentration to be equal to 0.01 molar. Now we can put this value on the formula of pH, and we can calculate the pH of this mixture to be equal to 2. So please note the relationship that we have used to calculate the H plus ion concentration in this mixture. It is M1 times V1 plus M2 times V2 equals to M3 times V3, where this M3 is the H plus ion concentration in the mixture. Okay, we will transpose V3 on the left hand side, and hence the dividing factor in this equation. We just saw the mixing of two acids. Now let us see the case when we mix an acid and a base. 100 milliliter of HCl, which has concentration of 10 to the power minus 2 molar, is mixed with 100 milliliter of 10 to the power minus 2 molar NaOH solution. We can quickly write the dissociation of both acids and base in this case, and we can also write the respective amount of H plus and OH minus ion produced from acid and base. Okay, so we will have 10 to the power minus 2 molar H plus ion concentration and 10 to the power minus 2 molar OH minus ion concentration. Again, we have used 100 milliliter of each of these solution. So to calculate H plus ion concentration, we will multiply this with 0.1 liter. Okay, now the acid and a base react in this manner that the H plus ion furnished by the acid and OH minus ion furnished by the base combine together to form a neutral water molecule. And this is how the neutralization between an acid and a base takes place. In this solution, we have equal amount of H plus and OH minus ion concentration. Okay, 10 to the power minus 2 times 0.1 H plus ion, 10 to the power minus 2 times 0.1 OH minus ion. So they will completely neutralize each other, and therefore the pH of this solution is going to be that of a neutral solution, which is 7 in this case. Okay, so if we mix an acid and a base in such ratio that they produce same amount of H plus and OH minus ion, then there will be complete neutralization between these ions and the solution will become neutral. So let us now move ahead and see a case when they do not undergo complete neutralization. So in this case, we have replaced HCl with H2SO4, and let us now see how this change will affect the neutralization reaction. We have to calculate the pH of this mixture. From our earlier illustrations, we know the dissociation of H2SO4 takes place like this. 1 mole of H2SO4 furnishes 2 moles of H plus ions. Therefore, 10 to the power minus 2 molar solution will produce 2 times 10 to the power minus 2 molar H plus ion concentration. Since we have used just 100 milliliter of this solution, therefore the concentration of H plus ion will be calculated by multiplying this molar concentration with volume. Okay, and H plus ion concentration is finally 2 times 10 to the power minus 3 molar H plus ion concentration we have in this solution. Similarly, the concentration of OH minus ion can be calculated in the NaOH solution, which is here equal to 10 to the power minus 3 molar. Now, the neutralization reaction takes place like this. 1 mole of H plus ion neutralizes 1 mole of OH minus ion. In this mixture, we can see that the concentration of H plus ion and OH minus ion is not equal. So one of these ions will get completely neutralized while the other will remain in excess, and that ion will decide the pH of the solution. So let us move ahead and see this neutralization reaction. We have 2 times 10 to the power minus 3 molar H plus ion concentration and 10 to the power minus 3 molar OH minus ion concentration. We can see that the OH minus concentration is in lesser quantity than its stoichiometric ratio. Okay, so 10 to the power minus 3 molar OH minus ion is going to be neutralized by 10 to the power minus 3 molar H plus ions. Okay, so 10 to the power minus 3 molar H plus ion will neutralize 10 to the power minus 3 molar OH minus ion, and therefore the remaining H plus ion concentration in the solution will be 10 to the power minus 3 molar, whereas there is no OH minus ion left in the solution. All the available OH minus ion have been neutralized, while the H plus ion is present in excess in this solution. So we have our H plus ion concentration, which is equal to 10 to the power minus 3. We will put this concentration into the formula of pH, and we can calculate the pH of this solution to be equal to 3. Thank you so much for watching this video. This video concludes the series of pH calculation. Please watch all the related 4 videos in this series. Thank you once again, and keep studying, keep practicing. I will see you in the next video.